Hello, welcome back for another lesson in trigonometry. So this is 8.3, trig ratios, finding side lengths. So last lesson we talked about describing the different ratios based on the angle we were looking at and having fractions that we could reduce in order to determine the ratio. Now we're going to continue to use trig, sine, cosine, and tangent to find missing side lengths in a right triangle. So next lesson, we're going to use trig ratios to find missing angles. So we're going to be looking at the same idea with sine, cosine, and tangent, and using the calculator a little bit more now. So you definitely need a calculator. Your phone would work, but what would be best would be either opening a Desmos tab or using Calculate 84 on your phone. So I'll use Desmos just so you can see how I'm typing it. But if you use your calculator and get the same answers as me, then that's totally fine too. So whatever works best for you. All right, so let's start by remembering sine, cosine, and tangent. So that's so, ka, toa. So sine is the opposite over the hypotenuse when we talk about side lengths. Cosine is adjacent over hypotenuse. And tangent, toa, tan is opposite over adjacent. All right. So, katoa. Okay, social isolation. All right, so we want to find these side lengths using trig. We want to make sure our calculator is in degree mode. So I'll pull up the calculator a little bit. Right now we'll just figure out what we need to find. So I am given this angle here, 28. I see I have a right triangle, which is great. And the angle I'm talking about is 28 degrees. So I'm going to label my sides based on this angle. All right, so this is my hypotenuse. This is my opposite side, and that's my adjacent side. So I'm in my head, I'm thinking so, ka, toa. And I want to see what I have. So what I have is I have the hypotenuse. I have a number for that. And I have to find the opposite side. So opposite and hypotenuse, I'm going to use so for SOHCAHTOA. So I'm going to say that sine is the opposite over the hypotenuse. The sine of what, though? It's the sine of the angle. So I'll say the sine of 28 equals opposite over hypotenuse. So that's x over 19. So I have a fraction on the right side, not on the left side, so I'll just put this over 1. All right, and I'll cross multiply, just like we did in chapter 7. So when I cross multiply, I have 1x, that brings me up here. 1x equals 19 times the sine of 28. So the sine of 28, that means I can't just do sine by itself, it has to be the sine of something. So this is what I'm going to put in my calculator. 19 sine of 28. So I'm just going to switch tabs and go to Desmos, a favorite of mine. I'll just click start graphing. And now I'm here. So I'm going to click settings and make sure that I'm in degree mode. Radians is just another way that we measure angles. That's not what we're talking about when we have triangles. We usually talk about degrees. So I'm in degree mode. That came from settings, degrees. Okay. So now I can just type what I need to calculate over here. So that is 19 times the sine of 28. So just type that in, 19 times, I did shift 8 for that. The sine, I could just type in sin, 28. There we have it. I know this is a little small because I like to zoom things out. So I just, again, did 19 times the sine of 28. Like I see right there. We'll round to the nearest tenth. I'm sorry I didn't write what to round to. That's 8.9. So 1x equals 8.9. Just divide by 1. Pretend there's a different number there. Sometimes there will be. So x equals 8.9. Cool. When I look here, I check to see that that's a logical answer. 8.9 is smaller than 19. Looks like it would probably be the smallest side. Maybe the adjacent side would be a little bit bigger. 12 maybe, 13, I don't know. But yeah, that's logical. Checks out. Let's keep it going. Same idea. 41. So that's the angle that we're given. This is the opposite, and this is adjacent. Opposite, adjacent. So that's going to be tela. If I'm not sure, I can scroll up. Opposite and adjacent. Yep, that's tangent. Okay, so the tangent is opposite over adjacent. So the tan of 41 equals the opposite side, so that's x, over the adjacent side, which is 32. All right, so I'll put this over 1 and cross multiply. Bring that up here again. So I have 1x equals 32 times the tangent of 41. So 1x will equal 32 times the tangent of 41. 32 times the tangent of 41. I'm just typing in tan. It's over here under functions if you want to click them instead. But Desmos is so smart and knows exactly what you mean. Okay, so 32 times the tan of 41, tangent of 41, 27.8. 27.8. Divide by 1. X equals 27.8. Nice. We check to make sure that's logical. 27.8. Yeah, that's smaller than 32. That 41 degrees is going to be smaller than this angle here. Yep, totally logical. Checks out. So let's see about this next one. Should I do a little oh, see? That's why I messed up. I got a stylus. Let's see. Okay. Mark the angle that we're using. 21. And let's label across from the right angle, that's the hypotenuse. Touching the angle, that's the adjacent. So I have the adjacent side and the hypotenuse. So when I have adjacent and hypotenuse, that's going to be cosine. So this is and the cosine is the adjacent over the hypotenuse. So that'll be the cosine of what? The cosine of 21. I'm going to erase that. Try to find a better angle, The cosine of 21 is the adjacent over the hypotenuse, x over 26. Maybe you could take it from here. Maybe you pause me. Okay, hopefully not mute me because that would be rude. And keep it going. So we have 1x equals 26 cosine of 21. Wow. Game changer. I'll just remove my keyboard because I don't need it. Oh, yeah, I do. Okay. Anyway, you don't have to worry about that. So then 26 cosine of 21. 26 cosine of 21. Yep. So that's 24.27. Let's round that together. 24.27. 24, 21. See if we got 24. So if we want to round to the nearest tenths place, we have to look at that 7. So that'll be 1x equals 24.3. There we have it, 24.3. Let's see if that's logical. Yeah, it almost looks like it's pretty close to the length of the hypotenuse. So we'll box it up. Call it a day. Just kidding. So those are the first 3. All right. So maybe you can predict what the next 3 will be like. Same idea, looks similar, wonder what's different. Let's figure it out. 33 degrees. Over here we got our opposite. Over here we have our hypotenuse. So I know that's so. So the sine is opposite over hypotenuse. So the sine of the angle is 33 is the opposite, 15, over the hypotenuse, x. Okay, looks like we found our difference. X is in the denominator now. That doesn't mess us up at all. We're still cross multiplying out here. So we have x, let me bring this up over here, x times the sine of 33. Not what that looks like. X times the sine of 33 equals 1 times 15. So we want to get x by itself, but we don't want to have to do any intermediate rounding. So in order to isolate x, I'm going to divide by the sine of 33. Get rid of it. Divided by the sine of 33. So I know that x equals, I do 1 times, why did I touch that? I do 1 times 15 to get 15. Divide that by the sine of 33. So I'm doing 15 divided by the sine of 33. Divided by, you press the little divided by symbol, sine of 33. 27.5. That doesn't look like I put a point there. 27.5. Alright, let's box it. Let's check that it makes sense. 27.5. The hypotenuse is the largest side. Yep, looks good to me. Let's keep it going. Maybe you're picking up some shortcuts as we go. Maybe you're like, I can do IXL from here. Maybe you're like, I want to listen to this again. Whatever works for you, you know? So here's our angle. Let's label. Our opposites over here, that doesn't help us solve the problem. We want to use what we're given and what we need to find out. So what we're given is this adjacent side and this hypotenuse. So I know when I have AH, that's ka. So the cosine is the adjacent over the hypotenuse. So the cosine of 43 is the adjacent, 36. over the hypotenuse that I don't know, that's x. So I just make it a proportion, cross multiply. So x times cosine of 43 will equal, 1 times 36 is already 36. I can save that step. And I want to solve for x. That's my goal, to find that missing side. So I'll divide by the cosine of 43. So I'm doing 36 divided by the cosine of 43 in my calculator. 36 divided by, I'll just type COS 33. Is that what it was? 43. I'll fix it. 36 divided by cosine of 43. Yes, sir. So that's 49.2. 49.2. Let's check that it's logical. Sure is. Boom, 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 boom. Wow, I'm having fun. See if you can challenge yourself. Set this one up without me. And then come back to it and see if you can do the same thing that I did. I'm just going to keep going, but I trust that you've already paused this and that you're checking it now because you already did it before. So you have integrity. All right, anyway, get over it. Okay. 72 is the angle I'm talking about. I know that the opposite of it is over here, and that touching it is right here. So that's the adjacent side. So I have O and A. Yeah, OA, isn't that a TV show? TOA is tangent. So I'm gonna move that O so that I have room. So tangent is the opposite over the adjacent. So tangent of what? The tangent of the angle, the tangent of 72 is the opposite, 25, over the adjacent x. And I'll just make that a proportion, cross multiply. That was large. And that over here, x times the tangent of 72 equals 25. Don't want intermediate rounding, so I'm just going to divide by the tangent of 72 on both sides to isolate x. So 25 divided by the tangent of 72. What do you think? 8.1 or 8.2? 8.1. Point is in the middle there. 8.1. 8.1. Yep, smallest side, way smaller than 25. We know the hypotenuse is going to be even bigger than 25. Makes total sense. All right, next page. Word problems before I excel. Okay. I remember I told you this is relevant in the real world. Blah blah blah. Not like you listen anyway. Half kidding. So here's a word problem. You can read it. I'll read it too. Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? Let's draw a picture. So we have a ladder and a house. So here's our house. and the ladder is leaned up against it. The ladder can be blue. Okay, we have our little right angle here. We know that. And then maybe there's some grass here. That's looking good. If the angle formed by the ladder and the ground is 68 degrees. So the angle formed by the ladder and the ground is 68 degrees. And the ladder is 12 feet tall. So this is the ladder here. We want to know how far from the base of the house did he place the ladder? So that's what I'm looking for, is that horizontal distance. How far? So we have a lot going on here. So usually the hardest part is setting it up, which is what we did together. You could practice doing this as well. We have this angle right here. This is what we're talking about. So let's label it. Here, this is your adjacent side. Here, this is your hypotenuse. That looks like another A. So I have A and H together, so I know that that's ka. So I have cosine. So the cosine of 68 is the adjacent over the hypotenuse. Okay, we have it. Now we're going to cross multiply and keep it going. So I have 1x equals 12 times the cosine of 68. So that's 12 cosine of 68. Let's do that in our calculator. I'm going to round that to 4.5. But because it's a word problem, we want to answer in terms of the context. So how far from the base of the house did he place the ladder? The ladder is 4.5, we're talking about feet, 4.5 feet from the house, from the base of the house. So that would be your answer. All right, one more of us together. My time's up. All right. It's too blue. A ramp is used to load suitcases on an airplane. If the cargo door is 7 feet from the ground and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? Okay, well, we know these are all right triangles. So you just cut the nonsense and just draw a right triangle. A ramp is used to load suitcases on an airplane. If a cargo door is 7 feet from the ground will be height, and the angle formed by the end of the ramp and the ground is 25 degrees. So that's here. So that's the ground. This is the ramp. How long is the ramp? So that's what we're trying to figure out. So that diagonal length, the hypotenuse. Oh, pardon me. So again, this is the angle. So we label over here, this is our opposite. This is our hypotenuse. OH. Oh, that'll be so cool. So cool. So the sine is opposite over hypotenuse. The sine of 25 is 7 over x. Make it a proportion and cross multiply. Let's bring it over here. X times the sine of 25 equals 1 times 7 is 7. Divide by the sine of 25. Divide by the sine of 25. Sorry, guys, it's on there. 7 divided by sine of 25. 7 divided by sin, 25. 16 points. 6. Let's see if that's logical. Yeah, it's larger than 7. Okay, so let's answer the question. How long is the ramp? The ramp is 16.6 feet long. You can think of this next time you're out and about traveling on a plane with your baggage being loaded. Sadly, that's not today. All right. Now practice on our favorite website, IXL. Again, Algebra 1, HH.4. So trig ratios find a side length. The reason we're doing the Algebra 1 instead of the geometry, if you were wondering, is because of the virtual learning. There's some trickier questions in geometry that we'd be able to work with you through if we were in person, but just to make it more accessible for you while we're not physically together. This is the decision we made so that you're still being challenged, but it's appropriate for doing it at home. All right, so this concludes the second week's lessons. You can practice, and then there's also additional practice that I'll post in Classroom if you feel like you need that as well. Okay, but we will be grading the IXL HH.4 to an 80 or above. Okay, have a great day. Bye.